Hi, welcome to my video on find the coordinates of a point given the radius and the value of theta, and the circle has 0, 0 center. So I have a graph here with XY axes, or actually a grid. So let's draw a circle on this axis, and let's put a point P on the circle, which has coordinates of x comma y, and theta is the rotation from the initial arm, which is this one, from the center 0, 0 out to this point, and the terminal arm of theta. Theta is the rotation from the initial arm, so this is the arm that's rotating up to here. So that theta is the rotation, and again the measure of the arc is the same size as the measure of the central angle. In quadrant 1, we drop a perpendicular to the x-axis, and the x-coordinate is whatever this number is. That's the distance there on the x-axis. That's the y-coordinate, so that's the height. And we have a radius r on this circle. And as a result, if that's the radius r, then this distance here, this point right here, is r comma 0. This is the point that's doing the rotating as we move around any number of degrees on this circle, the point r0. So as a result, we have a SOHCAHTOA, S-O-H-C-A-H-T-O-A, and the sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And as a result, we have sine of theta. Sine is the opposite over the hypotenuse, so that's the y over the r. The cos of theta is the adjacent over the hypotenuse, so it's the x over the r. And tan theta is opposite over adjacent, so tan is the y over x. I just reviewed that to make sure you knew it. And as a result of what we're going to do, so if you take this equation right here and you put the sine over 1 and cross multiply, you'll get 1 times y is y and r times sine. Because we have a proportion that's over 1, we're able to cross multiply. And again, put the cos over 1, cross multiply, 1 times x is x, and we get r times cos theta. And the tan, put it over 1, cross multiply, 1 times y is y, and we get x tan theta. But I'm mostly concerned with the cos and sine. So what happens, I'm going to use this, so again repeat, the sine theta is the y over r, and as a result y is equal to r sine theta, and that's true for any circle, no matter what the rotation is. Cos is x over r, so r equals x cos theta. So I'm going to use these two to work out the coordinates of a point, because the coordinates of a point is x and y. So find the coordinates of each point on the terminal arm of theta to the nearest tenth. So we're going to find the length to the nearest tenth. We could say to the nearest unit. So we have the coordinates of the point. The points is x comma y. So x is equal to r cos theta, and y is equal to r sine theta. So x, the radius is 4 cos 50 degrees. And we pick up our calculator, and 4 cos 50, So we turn on our calculator and we go 4 cos 50 degrees, and we get 2.57, so it's 2.6. 2.6. And so it's 2.6 is the coordinate, the point. And y is equal to r, which is 4 sine 50. And so 4 sine 50, we clear that. So 4, the sine of 50 degrees is 3.1 to the nearest tenth. So that's 5 or higher, so we add 1 onto the 0, so 3.1. So that means the point is x is 2.6 and y is 3.1 if you rotate on the circle. So what we have, if you think about it, we have a circle that has a radius of 4, so that's, pretend 4 units out like that. So this point right here is 4, 0. And so when we rotate 50 degrees, so 45 is in the middle, 50 is a little bit more. So when we rotate 50 degrees here on the arc, then the value of the x is 2.6 and the y is 3.1. That's the coordinates of the, if you drew a right triangle here, the x would be 2.1 and the y would be, x would be 2.6, the y would be 3.1, just to explain. And let's do another one. We have x is equal to r cos theta. So r is, the radius is 3, and the cos of 124. And so let's work that out. 3 cos 124. Clear it. 3 cos 124. And we got a negative. That's to the nearest tenth, so that's a greater than 5. So we add 1 to the 6, so it's a negative 1.7. Negative 1.7. And y is equal to r sine theta. R is 3, so the sine of 124 degrees. And we work that out. 3 sine 124. 3 sine 124. And we get, as a greater than 5, so that 1 added on to 4 gives me 5, so 2.5, positive. So 2.5. And just have a little explanation on that. Let's draw a little diagram to see if everything is okay. Just, we have a circle, and the radius is 3, so 1, 2, 3. Just mark off 3, like this. So the circle, center 0, 0, goes around and strikes all those 3's there. Remember, this point is 3, 0. This point here is going to be 0, 3. This one here is going to be negative 3, 0. And this one, x is 0, y is negative 3. So the point we're rotating is 124 degrees. So when you rotate, that's a 90. So let's say 124, pretend, is about right there. So the rotation for theta is this rotation. So that's the 124 degrees rotation. And we draw a terminal arm. So that means the coordinates of this point right here, x is a negative 1.7 and the y is 2.5. And if you drop a perpendicular to the axis, then you can see, straight down that is, that this is the negative 1.7 and this is the 2.5. And this makes sense because the x going over here is negative and the y going up here is positive. So the numbers fit. Again, theta is 124 degrees on this circle. So this is the point. The point 30 is rotating around the circle. So this point 30, when it goes 90 degrees, is 0, 3. And so when it hits right here, These are the X and Y coordinates for the 123 rotation. Hopefully everything is making sense. And we have a couple of more to do. The more we do, the better. And we have a radius, and we have a rotation of a negative 41. So X is equal to R cos theta. Y is equal to R sine theta. So R is 6.5 cos of, put the negative 41 degrees in the brackets, and 6.5 sine of a negative 41 degrees. So let's get two of those answers. Here we go. So we clear the calculator. So we got a 6.5, and we have a cos of a negative, that's a subtract, this is the negative, a negative 41, and we get 4.9, 4.9. And we do it again, clear it, and we get 6.5 sine of a negative 41, and we get, again, this is a greater than 5 or greater, so you add 1 to the 2, you get a 3, so it's a negative 4.3. And just to explain that very quickly in a diagram, so what we have is, we have a circle, and this is the initial arm, so we're rotating the radius of this circle, so this point right here is 6.5 comma 0. So this is the point that's moving along this circle, and as it moves a negative 41 degrees, so let's say this is a negative 41 here, almost close to the middle, so that's a negative 41, terminal arm goes out there, so there's the rotation, and so the coordinates of this point, X is 4.9 and Y is a negative 4.3. And again, if you drop a perpendicular, so X is 4.9 and Y, the height, is negative 4.3. Remember, the distance from here to here is 6.5. So these are the two coordinates of the point. And let's continue. X is equal to R cos theta. Y is equal to R sine theta. So the radius is 2.7, and we got the cos of 234 degrees. And here we got a 2.7, and it's the sine of 234 degrees. And we'll take our calculator. So we have, clear, 2.7 cos 234. And we get to the nearest tenth, a negative 1.6. Negative 1.6. And we'll do the sine, clear that. So we get 2.7 sine of 234, and we get negative 2.2, round to the nearest 10, 2.2, negative 2.2. And just to, again, show you, we draw a circle, and the radius of the circle is 2.7. So this point here is 2.7 comma 0. So this is the point. This is the rotation of 234 degrees. So that's 180. That's 270. So let's rotate probably over to here so far. So rotate right around like this. This is theta. So that rotation there is 234 degrees. So the coordinates of this point is negative 1.6 and y is a negative 2.2, and that makes sense because when we drop the perpendicular, the x is negative and the y is negative on that rotation. Remember, the reference angle is the angle that's in this corner here of this right triangle. So we've worked those out. So now I give you some practice to do. Let's see if you can work these out. Pause the video and see if you can work the ones I'm going to do now. Practice. Find the coordinates of each point on the terminal arm of theta. So we have a x is equal to r cos theta, and y is equal to r sine theta. So the radius of the circle is 2 cos 27. The radius is 2, and it's the sine of 27. So 2 cos 27. I just want to remind you that, just to show you that my calculator is in, notice my calculator is in degree mode, and because there is a radian mode that we're going to talk about later in another video. So my calculator is in degree mode. Got to make sure that. So it's 2 cos 27, and I get that's an 8 higher than 5, so we add 1 to 7, so it's 1.8. And we have 2, clear that, 2 sine 27, and we have, this is less than 5, so just 0.9. So the coordinates of the point are 1.8 and 0.9. Okay, you can draw the diagram. I'll just show you. So you have a circle. Again, there's the circle. And the radius of the circle is 2, so this is 0, 0. So this radius is 2 here. So this point is 2, 0. So as this point rotates around the circle, the values of x keep changing. So when I rotate 27 degrees, which is about, let's say, right there. So you rotate up, just estimate, you rotate 27 degrees up on this circle. So we drop a perpendicular to the x-axis. So the value of x is 1.8. And the value of y is 0.9. So that's a 1.8 from there to there, and that's a 0.9 up. Okay. And we have a couple more. Don't forget to pause your videos and work it out. See if you know what you're doing. So x is equal to r cos theta. Y is equal to r sine theta. R, the radius, is 1.6 cos of 100 degrees. And r is 1.6 radius sine of 100 degrees. And we work that out with our calculator. So we have, clear it, we got 6.1 cos of 100 degrees, and we get a negative 1.1 to the nearest tenth. That's 5 or greater, so you add 1 on, so negative 1.1. And we'll do, clear that, 6.1 sine of 100 is 6. Okay, so if you think about it, the point, the x coordinate is 1.1 and the y coordinate is 6. But just, I've done all the rest, so it's just able to do this one. So here's a circle. The radius of the circle is 6, so that means that that's a 6 from here to here. So this point is 6.0. So this is going around the circle, so that's a 0, 6. 6 units here is, this is a negative 6, 0. X is negative 6, y is 0. And right here, x is 0. On the y-axis, the x is 0, and the y is negative 6. But we're rotating 100 degrees, so there's 90. So let's pretend, just do an estimate. I'm not going to use a protractor. So we're rotating 100 degrees. There's the rotation. We draw, so this arm is rotating up to stop right there. Okay, and we drop a perpendicular to the x-axis. So the coordinates of this point is right there. Negative, that's a negative 1.1 right there, and that's a 6 right there. And this is the reference angle in the corner of the right triangle. And one more to do. Again, x equals r cos theta, y is equal to r sine theta, and the radius is 10. And cos of, now notice the angle is a negative 641. Because we have a calculator, we don't have to worry about changing the negative 641 to a smallest positive coterminal angle. So we got 10 cos, there we go, clear my calculator, and I have 10 cos negative 641, and I get a 1.9. And we do clear that, we get a 10 sine negative 641. That ends up to be 9.8. So the coordinates of the point is 1.9 for the x and 9.8 for the y. Now I just want to do a little tiny further explanation. Notice this angle here is a negative 641. If you had to graph that, you would start here and go negative 360 and some more. Like this, keep going. So I'm going to keep, but if you add 360 to this, so if we take a negative 641, so if we take a negative 641 and add on 360, you get a negative 281. If you add on 360 again, you get a 79. So let me explain. So if you did that rotation, like here, going around and around and around, you would end up right here. But by adding 360 and getting a positive 79, so now you only got to rotate 79 degrees right to here. So if you had a circle like this, and negative 641 is coterminal to 79, so if you rotate it 79 degrees on your circle right to there, and these coordinates are those right there. So what I'm going to do is check. Let's take 10. Let's check it. 10 r cos. I'll just check one of them. R is, the radius is 10, and we're going to do the cos of theta, and let's do 79. Instead of doing 641, which is the rotation around backwards like that to get to here, and that's a reference angle of 79, we would find that, let's do 10 cos 79. So clear it. 10 cos 79. And we get a 1.9. So this angle, negative 641 and 79, both end up with the reference angle of 79 in quadrant 1. Because the reference angle for negative 641 in quadrant 1 is the same reference angle as for 79, so you can replace negative 641 with a 79 and get the same values for x and y. That brings us to the end of our video, brings us to the end of this unit. I hope you enjoyed it, because the next video I'll do will be a review. And if you like my video, click the like button, subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.